difference between this one and the other one?
The other one is like you don't have to work your way down to 1. This one's 6, 5, 4, 3, 2, 1, blast off. When you say blast off, you can put the factorial symbol. If I have like this, 6, 5, 4, then I can go 6p3. I don't have to go all the way down to 1. This one I could also write as 6p6. This is actually the same thing. I don't know why I'm writing the numbers upside down. Like, not upside down, but it's like. So I start at the number 6 and I go down by 1 6 times. That's 66 is the same answer as well. Okay, the next one says, with new renovations completed at Holy Trinity Academy, there will be 7 entrances. How many different ways can a student come in for math tutorials? They enter and exit through any entrance. How many options of entering do I have? How many exits? So what is that? 49. Okay, I have an enter the school and exit through a different entrance. So how many enters do I have? Now I have to exit through a different one. 6, 42. Enter and exit through the same entrance. So how many options do I have to enter through? 7. How many can I exit through? 1. Truth. This one, the score at the end of the second period of a hockey game is 6-3. Remember, games can start at 0-0. They won't tell you that on the test. Matthew Kachuk was trying to determine how many different possibilities there are, because he was bored, for the score at the end of the first period. Even though he was there and could have saw it, that's fine. So it could have been 6-3 at the end of the first period, and they scored absolutely nothing in the second, correct? Or it could be like 5-2, or it could be 0-3, and they scored 6 in the second period. So there's all those options, right? He used fundamental counting principle and multiplied 6 by 3 and got 18. Explain the error in his reasoning. It shouldn't be 6 times 3. It should be what? 7 times 4, because he has the options 0 to 6 for the Calgary Flames options and 0 to 3 for the Oilers options. So it's actually 28 different outcomes they could have had at the end of period 1. Number 4 says, if each of the students in a class of 30 students is capable of winning any of the class prizes, how many ways are there for awarding first, second, and third prize? So if this is the first prize, this is the second, this is the third. How many options would be for winning the first? How many people? 30. Now someone won the first, so how many for the second? Then? And how much do you get again? That? What's the difference in B? A math prize, a chemistry prize, and a physics prize? 30, 30, 30. Because you could have like the valedictorian who like wins class standing and everything. It wasn't me, but you could. Sorry. So the math prize, 30 people could win it. The chemistry prize, 30 people could win it because it's not dependent on the math prize. And the physics prize, 30 people could win it. Which 3 times 3 times 3 is 27. And then 3 zeros, 27,000. And we flip over. So here we have 3-digit numbers are formed using only the digits 2, 3, 5, 6, 7, and 9. If repetitions are not permitted, and I told you for B, they're also not permitted. How many 3-digit numbers can be formed? So you have to box and hold because it's not permitted. So we would have 2, 3, 5, 6, 7, 9. So I'd have 6 options. Hold the 9. 2, 3, 5, 6, 7. 5 options. Hold the 7. 2, 3, 5, 6. Which is a 4. Which there's 123 digit options where I can't repeat. Now the next one says less than 400. Is 100 less than 400? 100? Is it less than 400? Is that a true statement? Yes. Is 200 less than 400? What about 300? What about 400? What about 435? What about 500? What about 600? What am I changing? Just the first digit for the most part, correct? So if I want less than 400, I just need to make sure that the first digit is less than a 4, right? Then it would be less than 400. So the only options I have are the 2 and the 3, which is 2 options, and then my catch is I have to box and hold them. The other 2 don't matter. If I start with a 2 or I start with a 3, the second 2 blanks can be whatever, and it'll be less than 400. You agree? So then I have 2, 5, 6, 7, 9, which is 5 options. Hold the 9, let's say 2, 5, 6, 7. 24, and then this would be 40. In order for a 3-digit number to be even, it can't start with a 0, but we don't even have a 0 option. So that was nice, even if we'd forgotten that. It was bad. But it's even, so it has to end in an even number. Now, some people will say, oh, 2, 4, 6, 8, and 0. Nope. We didn't have that as option. The only even number options we have are 2 and 6. So that's 2, hold the 6. Then we would have 2, 3, 5, 7, and 9, which is 5 options. Hold the 9, 2, 3, 5, 7, which is 4, and we get 40. Now, some people might say, well, odd's the exact same. Odd isn't the exact same because we have more odd options that they limited us to. So in odd options, still has to have 3 blanks. In odd options, we have 3, 5, 7, and 9. So we actually have 4 for the back. Hold the 9. Then we have 2, 3, 5, 6, and 7, which is 5 options. And then 2, 3, 5, and 6, which is 4, which gets us 80. Multiples of 5. What does that mean? It ends in a 5 or it ends in a 0. You just don't have a 0 option, right? So the only option we have for this one to be multiples of 5. 5, 10, 15, 20, 25, 30 is to end in a 5. So I have one option. I use up the 5. Then I have 2, 3, 6, 7, 9, which is 5 options. Hold the 9 and 4. So this would be 20. The next one says, determine the number of 4-letter words. This is important because it could be all the letters in shipwreck, or in this case, 4 letters that can be formed from shipwreck. Shipwreck has 9 letters, right? So this is going to be 9 options then, and it has to go down by 1 because if it's a word, we have just those amounts of letter tiles, right? Just like over here when I had English on this board. Okay? Now, how else could I represent this with a P? 9P, how many? 4 blanks. And what do we get for that then? 24. Now here it says the word must contain only consonants. So we still have 4 blanks. How many consonants are in shipwreck? 7, because there's 2 vowels, right? So this would have 7, then this would have 6, 5, 4. And because it's all going down by 1, I could also go 7P4. But what's my answer? The second one says begin and end with a consonant, but nothing about the middle. So we begin with a consonant, so I have 7. Then I hold 1 there, so what's about the end? 6. How many letters have I used up? I've used up 2 out of how many total? 9. So if I used up 2 out of 9, how many are left for this blank? 7, then 6. And what do we get? This one is begin with a vowel. How many vowels are there? 2. I and E, correct? But I hold 1. So I've used up 1 letter out of 9, correct? 1 letter out of 9 is used up. So how many do I have left for this blank? 8, then 7, then. So what do we get? The next one says contain the letter P. So if it contains the letter P, it could be in the first or the second or the third or the fourth blank, right? So we could show all 4 cases, or we could show 1 case and multiply it by 4. That's what I'm going to do. I'm going to put the P here, and then I'm going to multiply it by 4. So if I use up the P, I have 1. I've used up 1 letter. How many letters do I have left for second blank? 8, then 7, 6, and then times 4 cases. And what do we get?
1,344.
The next one says begin with a K and end with a vowel. So So if I begin with a K, how many K's are in shipwreck? There's one. End in a vowel. How many vowels are there? Yeah, 2. I and E, right? And then I hold one of them. Now, how many letters have I used up out of the 9? 2. The K and the E, correct? So how many are left? 7 and 6. So we should get 84. 7A says, how many different 3-digit numerals, so that's the same as numbers, just fancy way of saying numbers, can be formed from the digits 1, 5, and 8 if the digits can't be repeated? Does it say anything else, like it needs to be even or anything like that? Start with a 1, end in a 6? No. End in a 6. That wouldn't even be possible. I have 1, 5, and 8. So for the first one, I have 1, 5, 8, which is 3. And if I could repeat, I'd have 3, 3, 3. We agree? But it says can't be repeated, so I box and hold. So I'm going to hold the 8. Then I have 1 and 5, which is 2. Hold the 5. Then I have 1, which is 1. So I get 6. The next one says, how many 3-digit numerals can be formed using the digits 1, 3, 5, 7, and 9 if the digits may be repeated? So you can repeat them, correct? So we don't box and hold this time. And we have more digits. We have 1, 3, 5, 7, 9, which is 5 of them. And this one's going to have 5, and then this one's going to have, so it's 125. Then we have how many 4-digit numerals can be formed from 0, 2, and 3 if the digit may be repeated. This is a 4-digit numeral, and we're allowed to repeat. If it's a 4-digit number, what are we not allowed to start with? 0. It's the only thing. So you see 4-digit numeral or 4-digit number, can't start with a 0. So we have to start where the restriction is. You always have to start with the restricted one. So the first blank can only be a 2 or a 3. So how many options? 2. Now I'm allowed to repeat. So if I'm allowed to repeat, how many options are for the last 3 blanks? 3. So it should be 54. 27 times 2. Then this one says, how many non-zero numerals? So the number 0 can't exist. It doesn't mean you can't have zeros in the number. It just means the number 0 doesn't exist. Using some or all of the numbers 0, 1, 2, and 3 if the digits can't be repeated. So this is where you're going to have cases. You're going to have a 1-digit case, which could be the numbers 1, 2, or 3, because I can't have a 0-digit numeral. Whoops, I don't know why she wrote a 0. So I have 3 options. Or, and the digits can't be repeated, correct? So in my new case, I start off with all my digits again. This one could be 1, 2, or 3. Hold the 3, let's say. Then this one could be what?
2, 1, 2.
Yeah, 0, 1, and 2, which is 3 again. Or I could do a 3-digit number. This would be 1, 2, 3. Hold the 3. And I have 0, 1, 2. Hold the 2. Then I have 0, 1. Hold the 1. Or I could do a 4-digit number. 1, 2, 3 is my options. Then 0, 1, 2. Then 0, 1. Then 0. Could I do a 5-digit number? Is there enough numbers to make a 5-digit number? No, so I have to stop. So I'd run out of numbers because they can't be repeated. So it's going to be 3 plus 9 plus 18 plus 18, 36, 45, 48. And then we're going to flip over. So this one here says Mr. and Mrs. Wagner, which are my parents, want a family picture taken with their children, Jeremy, Jesse, and Crystal. My brother Jamie didn't make the mix because I had to have an odd number of people. So someone had to go. And Jeremy's the oldest, then Jesse, then Jamie, then me, and Jamie is out. Because I was like, sorry, bud, you're the last one. He's also the one that told me that my parents didn't love me a few times. So I had to kick him out, obviously. He's the funny one who actually, I'm recording. In how many different ways can all 5 line up in a straight line in the picture if there are no restrictions? Let's line them up. How many can be in the first blank? Then, which is 120. How else do we write it? 5 factorial, yeah, exclamation mark. How else do we write it? 5p5. All of those are the same. And we need to know the different ones because if they give it to us as a numeric response, like A, P, B, what's the values of A and B, you need to know how to do that. Now here it says the parents must be at either end of the line. So how many could be here?
2.
And? Yeah, some people say 2 and 2. You never left anyone there if it's 2 and 2, right? 2, leave someone 1, then 3, 2, 1. I always get a kick out of people who say, it didn't say you can't repeat. Well, there's not like an infinite number of my dad. Like, dad. You know, like my dad at one end. There's only one of them. So, 12. And then baby Crystal must be in the middle. I was the baby. Oh, I guess I'm still the baby, even though we're all old now. So, baby Crystal goes here. How many of her are there? 1. She's me. Then what?
4.
Then? How else could I write this? What if we have 4, 3, what does that multiplying by 1 do? Diddly squat. That's about all it does. So 4, 3, 2, 1. Blast off. How else could we write it? 4 factorial. Or we could write it as 4p4, which is 24. The children alternate with the adults. What do we have to start off with then? A kid. How many of them are there? 3 then. Then? What about here? 2 because it's a parent then. So we get 12. Here, there are 3 boys and 3 girls on a mixed league volleyball team. They want to take a picture of their team for the season where boys and girls alternate. How many different pictures can be taken? So I want you to draw your attention to D above. D above, we had to start with a child because there was more children than adults, correct? We went child, adult, child, adult, child, adult. This one, though, there's an even amount, and this is the one that's done terribly. Because there's an even amount, some of you will start with girls and some of you will start with boys and say, poof, I'm done. But you actually have 2 cases. Yeah, you can start with a girl or you can start with a boy, correct? So you can either show 2 cases or you can take your 1 case and multiply it by 2 because it's the same thing. So you could do girl, boy, girl, boy, girl, boy. And then some people will say, well, how's that different? If you can visually see a difference, which you could if you started with a girl, you started with a boy, if you started with me or you started with Matisse, you can tell the difference in the picture, right? It could be 3, 2, 1, 3, 2, 1, which is technically 3 factorial, 3 factorial. It could be written that way, correct? Because 3, 2, 1 is 3 factorial. 3, 2, 1 is 3 factorial. So they could represent it like that. And then this would be 3, 2, 1, 3, 2, 1. Make sure you have the multiplication dots. They're very important. So it's basically 72. It should be 36 times 2.